Yes, good day, class. I thank you so much for connecting and tuning on to Metric Hub. We are meeting once again, this time working on physical geography paper 1 grade 10. We want to prepare for mid-year. We want to prepare for end of year. We want to prepare for our end year of exams, end of year exams, November. Just note that we are going to work on the atmosphere and geomorphology, which is basically paper one. Those are the two areas of concern that we're going to look at: climatology or the atmosphere and geomorphology. So please understand that this is a guide towards your end of year examination. This is a checklist. This is just a blueprint which you're gonna use in order for you to understand what's happening in the or what to expect in paper one end of year examinations. So without wasting any time, let's just go through our paper. I'm sure that you know very well that you always have to know that there are instructions which you should read whenever you go to examination. Instructions are always very important. Please take note of that. And then we go straight to climatology. I'm sure that you are quite aware again that climatology, it forms basis of the atmosphere. The atmosphere actually is part of climatology. We are studying the climate. So the average weather conditions of a given place over a given period of time, which is usually a year. We talk about the climate in terms of weather, which is basically looking at the climate factors such as rainfall, temperature, humidity, cloud cover, wind speed, and wind direction. So all those we are going to discuss them under this topic. So we have got the diagram here, which we are going to use to answer the structure of the atmosphere. Match each of the statements with the letters A to F on the diagram, which is we are given there, which is, for example, 1.8 H as an example given there. You may use a letter more than once where it is possible. So we are given the structure of the atmosphere, which is given ranging or starting from D going up to the highest altitude, which is 400 uh, kilometers. So now, without wasting any time, the question says identify. Uh, we are supposed to identify the letter that represents each of the following statements. So the letter that represents which separates the atmosphere and the mesosphere. What separates the atmosphere and the mesosphere? I'm sure if you can look at this, if you can look at our diagram, identify the zone which separates the atmosphere and mesosphere, you can agree with me that when you look on the structure of the atmosphere, the party or the zone that separates the atmosphere from mesosphere, it is, we are saying G separates. We are saying that is G. Let's check on the notes again. Notes here for the sake of time. We just want to quickly work on to the question paper, and then we'll be, of course, identifying and explaining many other concepts as we go. Or whether process is okay within this layer, or whether process is okay, or whether process is okay within, or whether process is the okay within D. What happens is that we need to understand that or whether process is the okay within D. So what I want you to look at is that you should be able to understand the structure of the atmosphere. Yes, good. Let's continue, classic. I was just saying, it is very important for you to understand the structure of the structure of the atmosphere, so that if you are understanding and you are able to label the structure of the atmosphere, you can be able to answer all the questions that are there. So what I was saying is that we need to know very well that if you look at if you look at the structure that you are given in question here, it is quite important that you first of all, before you answer, you should be able at least to just identify and give the labels of these structures that we are given here. So I'm saying, for the interest of revision, we can understand that above 400 kilometers, we have got the exosphere there. We have the exosphere, which is around above 400 kilometers. And then what happens is that you must just be able to understand and label that is our thermosphere. That is our thermosphere, And then when you look at you should also be able to understand that is the what is the mesopause, which is actually just separating thermosphere from from mesosphere. So we are saying E is the mesopause, and then we are saying our B should just be mesosphere, and then we have got G. It is the stratosphere, and then we obviously have stratosphere G there, and then we have got the zone which is below the stratosphere. Obviously, is the what is the I mean the stratopause. G is the stratopause. G is the stratopause, is the stratopause, and then we are saying is the stratosphere. Obviously, the zone below the stratosphere, the stratopause is the stratosphere, and then we have got our stratosphere there. So eventually we are going to have our F, which is representing the tropopause. F represents the tropopause, and then obviously G should be representing the G must be representing the troposphere. So what I'm saying is, when given questions such as these ones, you should be first of all be able to identify and label. You should be able to identify and label these. You should be able to identify and label what is happening there. So in other words, if you are able to label the structure of the atmosphere, in any case, you will be able again to answer all the questions that would come above or be within the context of the question that we are given. So without wasting any time, let's therefore go to our questions. Let's go to our questions, and then we answer those questions that we are given here. Uh, so that we can be able to apply what we just discussed now to say that what is what. So we say that there's separate the stratosphere and the mesosphere. We say that G separates the stratosphere from the mesosphere, which we are saying that is the strato what is the stratopause, and then all weather processes occur within this layer. We are saying all weather processes occur within the troposphere. All weather processes occur within the troposphere, which is D. We are saying that it is occurring within the troposphere, and then the metals burn up in this layer. Number three, where do we have the metals burning? We are saying that they burn up within within the what? Within the thermosphere. Thermosphere is where we have got the metals burning. So it is the thermosphere which is represented by what? By A. A represents the thermosphere. A, I'm saying A, it is the thermosphere, and then separates the troposphere and the stratosphere. What separates the stratosphere from the troposphere? Number four. We are saying number four separates the troposphere and the stratosphere. What is it that separates that, which is supposed to be, you need to understand that it is the troposphere. Troposphere obviously separates. The troposphere separates the two. The tropos, the tropopause. The tropopause separates the troposphere from the stratosphere. So it is separated by this broken line or this broken boundary, which is representing the tropopause. The tropopause, which is F, it is separated by the what? Tropopause, which is F, tropo, tropopause. It is the tropopause that separates them. But we are saying the question wants you to give letters only. The temperature increases with the height. Temperature increases with the height. Where do we have temperature increasing with the height? What do we call that? It is called what? Temperature increasing with the height. We say that the higher you go, the cooler it becomes. But in this case, number 5, the higher you go, the temperature increases or the hotter it becomes. So it is supposed to be represented. We are saying that condition, this one is called temperature. We should understand that that is called temperature inversion. Temperature inversion, which is an increase of temperature with height. An increase of temperature with height, it can be represented by the mesosphere. We can have increase of temperature with height, which we are seeing here. We are saying the increase of temperature with height, we can find it that we can find it on what? We can find it on mesosphere. It can be in mesosphere. It can also be found within the what? Within the troposphere as well. So we are saying it can be B or D. It can be D. It can be B or it can be D, which we are saying that if you look here, temperature increases with the height in the what? In the troposphere. It can also increase in height in the what? In the mesosphere. That we can say it can be B or D, can show the increase of temperature with height. And then separate mesosphere. Number 6, it separates mesosphere from thermosphere. Mesosphere and thermosphere, mesosphere and thermosphere, you see that they are separated. Mesosphere and thermosphere, they are separated by mesopause. Mesosphere and thermosphere, we are saying what separates them? They are separated by what? By the mesopause. Mesopause separates the thermosphere from what? From mesosphere from thermosphere. It is letter E. It is letter E that separates that. It is letter E, which is the mesopause. Is E, which we are saying is what? Mesopause. And then the ozone layer is found in this layer. The ozone layer is found in this layer. The ozone layer, we remember we said that ozone layer, it represents the thin layer of that protects the earth from overheating. So where do we find the ozone layer being protected? Which is the ozone layer is found protected by C, which we are saying is the stratosphere. C represents, we are saying it protects the ozone layer. Where the ozone layer is found, it is found in what? In stratosphere. C, it is found in stratosphere, which is stratosphere, which is C. So then what I'm saying is, when you are able to give this class, when you are able to give this diagram, if you are able to label it, I'm sure that you will never get answers wrong there. So now, what I want you to take note of is that these questions quite this is one of the major areas of concern which we find from our exams, or which we find our examiners interested in asking quite a lot of times. So you should be able to answer it properly and without any problems. So question 1.2, you match terms in column B with descriptions in column A. You write only the letter next to the question number, and then we are given that we are given the category of gases which occur in different amounts at different times. The amount of gases, the category of gases that which occurs in different, the category of gases which occur in different amounts at different times. What do we call that? Amount of gases which occur in different amounts, and also at different uh heights, or different times, which occur at different amounts and also different times. So what do we call that category of gases? It is called variable. It is called variable gases. We call that variable gases, which is what? Which is G. It is called variable gases, which is G, and then refers to the direction of a slope faces in relation to the sun. The direction to which the slope faces in relation to the sun, we call that aspect, which we talk about with regards to the orientation, how much, or we can define it also in terms of the hemispheres, southern hemisphere or northern hemisphere, in terms of temperature distribution. So what you need to understand is that the orientation of the slope in relation to the sun, or the direction to which a slope faces in relation to the sun, we call that aspect. It's called what? It's called aspect, which is I. It's called aspect. And then change of state from gas to liquid. When something changes from gas to liquid, what do we call that? Change of state from gas to liquid. From gas, the change of state from gas to liquid, it means the item, it is what do we call that? Hydroscopic nuclei? Not really. It is called the crystallization. Crystallization, change of state from gas to liquid, is called crystallization, which is F, crystallization. And then this gas makes up 78% in the atmosphere. The gas which makes 70% in the atmosphere, I'm sure I remember the distribution, or the amount of gases that we have in the atmosphere. We have got what? Nitrogen. Nitrogen forms 78% in the atmosphere. 78% is nitrogen that we find in the atmosphere, and then lines joining all places having equal temperature. When we talk about temperature, obviously we talk about isotherms. Isotherms are lines that we find on the map. We can find them on the map joining places of equal temperature. It is called isotherms. Isotherms, which we are saying that it is what? It is D. D is isotherms, which represents lines that joins places of equal temperature. We call that isotherms. And then minute solid particle, minute solid particles found in the atmosphere that forms the nucleus for drops to form. Minute solid particles are found in the atmosphere. Minute solid particles that are found in the atmosphere that forms the nucleus of droplets to form. We call that hydroscopic nuclei, meaning to say that they are not visible. They are very small. Hydroscopic. These are hygroscopic nuclei, which we are finding that they are small particles of moisture which are found in the what? In the that are found in the atmosphere. in resulting in condensation, which we are talking about the formation of the nuclei of raindrops. We call that it is, which is C. And then type of rain usually found in Gauteng. The type of rain that is usually found in Gauteng, we actually mostly have convection rainfall. Convection rainfall, which is caused because of it rains and then temperatures goes up and then it rains again, which we say that convection rainfall, it is the one that is normally found there. Convection rainfall. Convection rainfall, which is a convection rainfall, is the type of rainfall that is normally found in Gauteng. And then the total amount of energy received from the sun, the total amount of energy that is received from the sun, we call that insolation. Insolation. Insolation is the total amount of energy, total amount of solar energy. We call that the energy from the sun. We say that is what? Insolation, which is letter B. Letter B, insolation. So minute means very small. Minute means very small. Means very small. And then we have got refers to the synoptic weather map below. Synoptic weather map chart, which is given 06 June 2012. So we are given Cape Town. We are given the weather conditions that are of in Cape Town there. We are saying high pressure. We have got our high pressure. We have got our low pressure. Low L means low, and then H means obviously high. And then what we need to understand is that we are given the ISO bars that are measuring, showing our various pressure regions that are given there. And then what happens is that ISO bars, you need to know that these are lines that are found on the map, which are joining places, which are joining places of equal atmospheric pressure. Atmospheric pressure, we can show it through diagrams that can be represented by isobars. So we are saying these are lines on the map are joining places of the same. They are joining places of the same atmospheric, joining places of the same atmospheric pressure, of the same atmospheric pressure. So we use isobars to identify places which are of the same, pressure. So as you can see, we are seeing, for example, I can give an example of this one, which is 972, 976, 980, 964, 988, going up like that. So now what we need to see is that this area that is shown by each of these lines, when we follow this place or this region which this line is going around, it is showing is equal pressure within this area where the line is passing. So what we need to understand is that these are called isobars. They identify pressure areas of the equal of which have got equal pressure. That is what you need to know. And then give the isobaric interval of the synoptic weather map. The interval, we are saying, when we talk about the interval, we mean the differences from one isobar to the next. We look at the interval of one isobar to the next, which we can give according to this map that we are given here, where we are having a cold front, which we are having this cold front, where we have this cold front here. What is happening is that we are saying the interval is from 972 to 976, and then 976 to 9 we go. So now it's 980, 980 to 984. So now what we are saying is that the interval is the difference from one isobar to the next, which is given like to say that we can say 976, 976 minus 972, which we can find out that 976 minus 972, which will find out that the isobar, the isobaric interval is what it is for. So we are saying when you get that 4, you need to be able to know that this is called hectopascals. We measure pressure in hectopascals, so which you can give as HPA. I'm saying you get it by subtracting the differences from between one isobar to the next. So now, with what you can find is that it is 4, which is 4 hectopascals. That is how you find it. I'm saying we are using, for example, we are using even here, is 9, 10, 16, 10, 12. So if you can look here, 16 minus 12, you would also say 16 minus 12, you still find what? You still find 4. That is what we are saying, or that is how you get this. That is how you get the answer there. Which cell, A or B, which cell, okay, why cell A referred to as a high pressure cell? Why is cell A referred to as high pressure system? Why is cell A referred to as high pressure system? What you can see is that we are saying if you look on the interval of the isobars that we are talking about, cell A, we are seeing the pressure, it is high from the center and then it decreases as we go out. So what happens is that it contains, or it has the highest values, it has the highest pressure, or it has A is the highest pressure at the center. As you can see, our saying 1020 is the highest pressure that we can see, which we can find out that when you go from there, there is 1020, and then we go down 1020, 1016, and then we go going down, going down. So what we are saying is that it is having the highest pressure, or highest pressure is found at the center there. So that is why highest pressure, highest value is found. Pressure which is given by the what? By the value of this 1020 thing. So we are saying highest pressure is found at the center. Highest pressure is found at the center. So we say that it is high pressure. In any case, what you need to know is that when we are talking about pressure systems, I can be able to show you through different illustrations. We can have different illustrations. So when we are talking about high pressure, so we are saying it's 1020 here. We have got 1020. We have got our 1020 there, our 1020. So what happens is that the highest pressure is found at the center. What are we saying? We are saying we have got 1020 here, and then we have got 1016. And then if we are going to have another isobar, we are going to have it also, which can also be able to be given here, which is going to be saying is 1012. So this is called a high pressure. This is a high pressure because we have got the highest pressure that is found at the center there. Opposite to that is when we see a low pressure can be found also, which can also be different from what we just said or what we just illustrated there. If it is a low pressure now, it would also have a different scenario, which can also be represented by L. And then when it is like that, we can now say that we have got 10, 12, we have got 10, 16, we have got 10, 20. So now, as you can see, pressure is in terms of in terms of low pressure. Here, pressure, in this case, our pressure, it increases with the distance from the center. Pressure increases as we move from center. And then in this case, pressure, it decreases from the center. So we can say that this is a high pressure, this is a high pressure, this is a low pressure, which is given by H, which is high, and also a low pressure, which is given by L. So you should be able to understand this so that you won't have problems in regards to climatology. So uh, let's go to the next question. The next question is saying, identify the season represented in the synoptic weather map. Identify the season. So I was saying, in many cases, you should always be able to see the season. How do we know the season? We can also use the date. The season can be identified through the date that is given on the map. We can use the date. The synoptic weather map, it is uh, 1 June 2012. I'm saying when you check the date, you will be able to tell that you can be able to tell the season of that map, or when the map was taken. So now we are saying June, according to you, you know June. If you talk about June, June is what? It's winter. When it is June, we know that it is winter. We can as well be able to understand in terms of here, as you can see again, we have got also the presence of the cold front that I've talked about. The cold front that we are saying that cold front, including when it influences the weather of Cape Town, we are having Cape Town here, and then we have got our cold front. So the cold front also identifies that this we can have it as to say it is what? It is winter when the cold front also influences weather in Cape Town. We can also maybe look in terms of the positioning of what? Of the high pressure system. If it migrates northwards, when the high pressure is migrated towards the north, we can also talk about that it's winter in terms of that question. So what is the identify the season which is given here? The season that we need to know is that it is what? The season which we are referring to, we're saying is that it's winter. It's winter because we said that is because of the presence of the cold front. It's also because of, okay, the question is given below. Give two evidence on the map that can also support our answer. We said that the evidence to this question, we said that we have got our date that is given, which is 6 June. 6 June is given as our date there. We have got the date given, date given uh, is June, which is winter. We have got June. June means winter. We have got June in our seasons in South Africa. June, we have June. When it is June, it is in winter. We also talked about the migration of the high pressure, migration of the high pressure to the north. When the high pressure migrates to the north again, the migration of the high pressure cell to the north, as you can see there, it is migrating, it is almost around Zimbabwe there. As you can see, what it means is that this, it has gone up instead of it being in the lowest region of the Southern African map there. So what happens is that it is almost entering into Zimbabwe there, according to the map that we are given here. So the high pressure cell is migrated to the north, which represents that it is winter. And then we can also talk about the presence of the cold front that I was talking about, that we are given a cold front here. We are given a cold front. The cold front that we are given also is represents, we are saying the presence of cold front influencing weather in Cape Town. It indicates that it is what? The presence of the cold front that is influencing the weather in Cape Town also represents that it is winter. So what we are saying is that 1.3.5, we are given that the date, we are given the position of the high pressure cell, and also the presence of the cold front that we are seeing affecting our cold front, that is also showing almost our weather conditions, which are showing also that is almost overcast. So now let's go to the next questions. Let's just answer the next question. Uh, refer to the station, weather station of Cape Town enlarged, and then state the main factor which that will cause a change in weather conditions of Cape Town in 24 hours. So we are saying, if you look at uh, 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 the main factor, the main factor, the main factor that can change, that will cause a change in weather condition, main factor change in weather conditions of Cape Town in 24 hours. What you can see there is that we are seeing, if we go on the map, Cape Town, and then we are seeing that the cold front is approaching. The cold front is approaching there in Cape Town. And then, so what is it that can also change the weather? It is obviously the presence or the approaching cold front. So, question A, we are saying what can change? State the main factor that will cause the change in weather conditions. We are saying the main factor is the what? Is the cold front. The cold front can change the weather conditions in Cape Town in the next hours that are coming. The cold front can change the weather conditions in there. And then we are also asked to say draw. Next question is saying draw. We are saying draw weather station for Cape Town with the following changes. The temperature decreases by 14 degrees Celsius. Cloud cover increased by 4/4 or 8/8. When we talk about this, this is an overcast. This is an overcast weather, overcast condition, which we are saying that it is what is cloudy. The weather is cloudy, which is 4/4. So again, the wind direction changes to southwest. Southwest, it means it must move. The wind must move southwest, and then wind speed increases by 5 knots. It increases by 5 knots. The wind speed increases by 5 knots, and then the weather, we are saying that is the wind speed increases by 5 knots. Dew point temperature remains constant. The dew point temperature remains constant. So we are supposed to go and look at we are supposed to identify the weather factors or the weather phenomena that are being given in this regard. So when we look on our weather station, our synoptic weather map, we are given that Cape Town, which is given here. This is our Cape Town. This is our Cape Town weather conditions that we are referring to. We are given this as our Cape Town weather conditions. So now, what is given is that we have got a wind direction. In this case, it is northwest, but now we are given again that according to this side, according to the weather changes, it must change to southwest. And then we also have overcast conditions, and also we have got overcast. We are given overcast wind direction southwest, wind speed 5 knots, wind speed increases by 5 knots, wind speed increases by 5 knots, it increases. So here we have got it was 10, so it should be 15 as it increases by 5 knots. And then we are also supposed to understand that the dew point temperature remains constant. Our dew point temperature, it remained constant, which is our dew point temperature was 13 degrees. So now it did not change. The temperature did not change in this case. Temperature did not change. So now, what are we supposed to do? And then one other factor that I want us to look at is that the temperature decreased by, it decreased, it decreases by 14 degrees. It decreases by 14 degrees. So from the temperature that we are given, it must decrease by 14 degrees. So our temperature, we must minus 14 degrees, and then our cloud cover must be overcast, our wind direction must be southwest, and then the wind speed increases by 5 knots, and this one remains constant. So in other words, what we need to do is, let's start by having the cloud cover. We have always to start with the cloud cover. Is what is we are supposed to start with our cloud cover. Our cloud cover, it is saying that it is overcast, which meaning to say that it is totally covered. The cloud cover, the weather condition is overcast. So we are saying it is supposed to be overcast. It's supposed to be overcast so that we can see that everything is covered, is shaded. We have got overcast conditions. We have got overcast. We have got our overcast conditions. And then we are told again from the overcast conditions, one thing that we need to know is that this is overcast. And then we are also supposed to know that the wind direction should be southwest. So our wind direction must be southwest. Our wind direction must be southwest. So our wind direction must be southwest, so that we can be able to understand that it is known that it increased. Initially it was 10, and then it's given that it increased by 5. So therefore it should be increasing by 5, and then increased by 5 knots, and then the wind direction we have measured, we have marked it, and then what else? We are told that the temperature, air temperature decreases by 14 degrees. The air temperature decreases by 14 degrees. Our air temperature was 18. 18 minus 14. Our temperature was 18. 18 minus 14, we get 4. It should be 4. It should be 4. It decreases by 14. Air temperature decreases by 14. So we are saying our air temperature, so from 18 minus 14, we have got our 14. We have got our 14, 4. Because the initial temperature, our initial air temperature is that it was 18 minus 14, so that we can get our temperature now, which is going to be what? Which is going to be what? 4 degrees Celsius. And then we also want to understand that the dew point temperature remains constant. So we have got, so we can have our 14 our four, sorry. We can have our 4, and then we are also having our 13, which is remaining constant. So what is given here is that our we are given that this is overcast. So our overcast is given. We have got our wind direction, which is southwest. We are given our wind speed increased by 5 knots. So we are saying it increased by 5 knots. So we now have what? Our wind speed 15 knots from what? From 10. And then our dew point is also given there as what? Our dew point remains constant, which is our dew point, which is given there. So now we are saying when you draw this, you are done. We have managed to draw the what? That graph or the synoptic weather map that is actually asked of you. You have drawn a weather map that is asked of you, which is showing our 8/8 or our 4/4 weather condition or cloud cover that is given there. That is what is expected of us. So before we explain why the winds will generally be stronger at sea than in area B. Explain why the wind is generally being stronger in area C than in what? Than in area C than B. Why is it stronger in area C than in B? That is what the question wants us to answer there. Let's see what is what. Why the wind? Explain why the wind uh, why the wind is stronger in area C than B. So we are saying we are given B, we are given C. So the question is saying, explain why the wind will be stronger in area C than in B. Why do we have wind being stronger in area C than in B? So the thing is, as you can see, you should be understanding this one in relation to the issue of isobars in the issue with regards to the issue of isobars here. So when you see that the isobars are nearer in they are nearer in area C, or isobars that you are seeing there are also in B, they are not so close to each other. I'm saying the interval or the closeness of the isobars in C, they are very close, isobars, close isobars in C, but in B you see that they are what? They are far apart. B, they are far apart. B, they are far apart. So what we can see is that what we need to say is that this actually shows that pressure gradient is actually steeper in what? In area C, unlike area B. It is what? It is, we are saying the pressure gradient in area C is steeper, and then or is the pressure gradient is weaker in what? In area B. The pressure gradient, as you can see here, the closer the what? The isobars, closer isobars shows a what? A steep. We are saying this is steeper. This B is what? Is gentle because of the isobars that are there. Is what it shows that it is gentle. It shows that that is gentle. So if we go here now, we are saying isobars in C are very close. They are very closer together, showing steeper. gradient, steeper gradient than B, which is a which has got a more gentle gradient. We are saying it's a more gentle gradient shown by uh, far apart isobars. The isobars are far apart in what? In B, which represent that it's a more gentle gradient, unlike in C, which is actually steeper, which is actually showing a steeper gradient, than what is in B. So we are given, refer to the diagram below, which shows greenhouse gases that contributes to global warming. Greenhouse gases that contributes to global warming. So now, what happens is that you should be able to understand these questions again. The issue of greenhouse gases, the issue of global warming. We are seeing that the absorbed sun, we have got reflected sun, we have got absorbed by the atmosphere and the earth. We have got also deforestation, cutting down of trees, carbon fluoro gases that we are seeing, oil and petrol engine. We talk about fumes there, fossil fuels burning at the edge of the atmosphere. We have got the greenhouse gases from the fossils. Also, all these are given here. So now, what we need to understand is that greenhouse gases that are contributed or that are contributing to global warming. So now, the question is saying, what are greenhouse gases? What are greenhouse gases? Greenhouse gases. Greenhouse gases, basically we refer to these are gases that are emitted into the atmosphere that trap heat and cause annual temperatures, or that causes global increase in temperatures. Greenhouse gases are carbon gases, carbon pollution gases, emitted from various sources into the atmosphere, which causes global warming. So now what you need to understand is that greenhouse gases are carbon gases that are emitted in the atmosphere. They are pollution gases that are emitted into the atmosphere from various sources. And then what they do is they causes global warming, or they can cause changes in what they can result in climate change. We can talk about increase in global temperatures, which can actually global warming, or we can say temperature increase. Temperature increases. It can be caused because of the greenhouse gases that we are talking about. So that is what we mean by what? By greenhouse gases. How can greenhouse gases cause global warming? How do greenhouse gases cause global warming? What they do is that these gases allow sunlight to pass into the atmosphere, but blocks earth sun. When what happens is that global warming is caused because of greenhouse gases. They allow overheating of the earth, overheating of the earth, by avoiding the they actually avoid by avoiding or blocking by avoiding the uh, terrestrial solar radiation solar radiation to escape from the earth, to escape from the earth into the atmosphere. So what you need to understand is that greenhouse gases, the incoming solar radiation is allowed to pass through to the earth, but the outgoing, when the earth hits or when the heat is released from the earth surfaces into the atmosphere, it cannot be released. It is trapped uh, into within the lower levels of the atmosphere, which can cause increase in temperature. So there is overheating of the earth because the outgoing solar terrestrial radiation is not released, is not able to escape into to go up into the atmosphere. And then explain how deforestation contributes to global warming. How deforestation, what it does is that explain how it contributes to global warming. So what you need to understand is that we are saying deforestation is cutting down of trees. Is cutting down of trees. What is deforestation? So removal or when trees are cut down, uh, what happens is that cutting down of trees is where we are getting our answers from. Our answers are coming from the effect of cutting down of trees. So carbon dioxide, it reduces the absorption of absorption of carbon dioxide. It reduces the absorption of carbon dioxide by the trees. So we have got an accumulation of gases that can also be found in the atmosphere. And then what happens is that we also have it also the trees, when trees are cut down again, they also have to when they are cut down, we are saying carbon dioxide stored in trees is released back into the atmosphere. It is released back into the atmosphere, which is a contribution of global warming. And then it is a contribution of global warming. We also have uh, the when trees cut. So we are talking about when trees are cut and then when they decompose, they are releasing the carbon dioxide back into the atmosphere, which is one big issue that we need to understand. And then carbon dioxide is a greenhouse gas that absorbs the earth's heat and also prevents it from escaping into the atmosphere, causing what? Causing the increase in temperatures. Carbon dioxide is therefore a greenhouse gas which absorbs or prevents the escape of heat from Earth. it can actually prevent the escape of it from the earth, because the carbon dioxide that we are talking about is also being trapped in the atmosphere there. And then we want to look at two consequences or two effects of global warming. Two effects of global warming. One, global warming, the effects of global warming, we can talk about uh, one, acid, it can result in increase in flooding. We can say flooding of coastal places. Coastal places, they can flood. Places that are close to the sea can flood because of the melting of ice. We can talk about extinction of both. It results in extinction of both plants and animals. Some animals and plant species, they can finish because of global warming. They die because the temperatures might be too, they might be too much, and therefore they can die. Certain plants and animals cannot survive them. And then we can also talk about air pollution. Air pollution that causes, you can have problems of air pollution resulting in acid rainfall. In acid rain, what does the acid rain? It also destroys both plants and animals. We can also talk about uh, problems to do with health problems to people, increased health problems and diseases that can also affect humans. Diseases in people increased. We talk about EG, we talk about cancerous diseases. Cancerous diseases are caused because of what? They are caused because of global warming. Cancerous diseases are an example that we can have, which are also caused by this, which also results in high death rate. People die a lot when temperatures are too high. People die a lot and they become, which is also another problem that we can talk about. Uh, we can have also runaway fires caused by high temperatures. Caused by high temperatures. We have got problems of fires that can be caused by high temperatures, which can destroy our. We talk about these are called veiled fires, runaway fires, which we are saying they are called veiled fires, which destroys our what? Our animal habitats, resulting in destruction or a reduction in biodiversity. That is one other problem that we need to understand. And then question 4.5 suggest strategies that can people implement in their daily activity to reduce greenhouse gas emissions. So what we are saying is, what are the measures that people can put in place to reduce the problem of what? Of carbon, to reduce greenhouse gas emissions. One, we can talk about uh, planting of trees, planting more vegetation. The vegetation, we said that it can absorb the carbon gases. It can be used to absorb the carbon gases that we are wondering or we are worried about. We can talk about also recycling. We can also talk about recycling and reduction of waste. Recycling or a reduction of dumping of waste. Dumping of waste. We are saying proper waste disposal is very important, such that we cannot have the methane being released. We talk about use of vehicles. Use of vehicles with efficient engines, efficient car engines, which resulting in less pollution. The car engines, they can actually do a complete burning of fuel that can result in less pollution, as we can see. We can also talk about encouragement of use of public transport. Encouragement of use of public transport. Public transport, what does it do to reduce pollution? Pollution is reduced when we use public transport. Education of people. People must be educated. Education, and we talk about campaigns or educations of people on importance of clean environment. Education of people on effects of global warming. When people are educated about global warming, they won't do it a lot, and therefore we are able to save our climate. So now what we are saying is these are measures that can be put in place to reduce the problems to do with what? With greenhouse gases. We can also talk about use of any other sources of fuel which are environmentally friendly. Use of environmentally friendly sources of fuel, which can be, we can talk about gas, we can talk about solar energy. So we can talk about solar energy, which are better in terms of emission of pollution gases that we are talking about. So we have got question 1.5 that is actually given to say illustrate types of rainfall. Illustrate the types of rainfall that are given here, and then we are given, this is, we can say this is a mountain. It can be a mountain that we are given here, and then we are also supposed to understand that mountains, or we can say the relief, in most cases, whenever we see mountains, we are supposed to understand the windward side and the leeward side, which is going to result in what? In some form of rainfall. Which actually results in some distribution of rainfall that is unequal. So now, what you need to understand is there is also another form of rainfall which we are given, like we can talk about which can be also number diagram A and B. Diagram B, we can actually see that this can be also some form of frontal rainfall, which can be formed because of this maybe front that is forming there. We can have a frontal rainfall forming in this case. We can also have frontal rainfall forming in that case. So now what we need to do is that let's have question 1.5.1, identify the types of rainfall in diagram A and B. So we said that A, it is showing that we can say this is A, we can have relief rainfall. I'm sure that the moment you see a mountain, we say that it is associated with relief, or we can say it can also be called orographic rainfall. Relief, I'm sure that if you can remember from our teaching, this is also called orographic rainfall. So we said the other one is also called what? Frontal rainfall. Frontal rainfall, which we have already given there. Frontal rainfall. So what trigger action caused the development of the types of rainfall in diagram A and B? So we are saying in diagram A, as we can see, what is facilitating the formation of rainfall in this case? We are saying the presence of a mountain range, presence of a mountain, and then B, what is triggering the rainfall? We are seeing that it is the presence of what? Of the frontal conditions that are present there. Frontal conditions that we can also see, they are also resulting in what? In possibilities of having those forms of rainfall that we are seeing there. And then describe the rainfall occurring in B. It is actually the rainfall that is occurring in B. As you can see, we are saying the rainfall that is occurring in B. Describe the rainfall occurring in B. What we need to understand is that this is actually continuous rain over a wide area that you can see that we are seeing the rainfall is actually covering a wide area. So what we are saying is that it is we have got continuous rainfall covering a wide area, continuous rainfall covering a wide area, and then we also have a wide area, the rainfall in other ways again, and the rainfall is actually very calm, and it is very calm and steady. You're gonna see a very steady and calm rainfall that we can see there. And then in a paragraph of 8 lines, discuss how rainfall in AE is formed. How rainfall, we are talking about AE, we said AE, this is the relief. Describe the formation or discuss the formation of relief rainfall. So what you need to understand is that relief rainfall, how relief rainfall forms. It is relief rainfall, it occurs when warm moist air blows off the ocean into the mountain. Relief rainfall occurs when warm moist air when warm moist air when we have got warm moist air blowing, when the warm moist air blows off the ocean, it blows off the ocean and then towards the mountain. It blows off the rain from the ocean towards the mountain. It actually to warm moist air is forced to rise. Warm moist air is forced to rise. Is actually forced to rise by the mountain. It is forced to rise by the mountain, and then it cools down to form clouds. And cools down to form clouds. Rainfall is then falls. Rainfall then falls. We have got rainfall that falls also uh, it falls on the side of the mountain that faces the what? That faces the mountain, the ocean. Rainfall then falls the side of the mountain that faces the ocean. Rainfall falls the side of the mountain that rainfall falls the side of the mountain that faces the ocean. And then what we need to understand is that the other side of the mountain, which we said that it doesn't receive rainfall, we said that is the leeward side, the leeward side of the mountain. The leeward side of the mountain is then left without with dry air. The leeward side of the mountain is dry air. It has dry air that actually blows down the mountain range. It blows down the mountain. It blows down the mountain. Then what we need to understand is that when this air blows down the mountain, we have got also the dry air that descends the leeward side, continues to pull moisture out of the land, which we are saying it remains dry there. We now need to understand that the warm dry air descending the mountain, that is descending down the mountain, which we are saying on the leeward side. On the leeward side, it continues to pull moisture out of the land, continues to cause the land to further dry up. So basically, this is what you need to understand. I was saying that you should be able to see that when we are looking in terms of the relief rainfall, you should be able to understand these two things to say that we have got the escarpment there. We have got, we are saying we have got the leeward side, which is going to be dry because we are saying that the moisture or the rainfall is only rising from the side of the ocean. We have got an ocean here which is causing warm moist air to rise, and then condensation occurs there. When the condensation occurs, rainfall falls on the side of the ocean, which on the side of the mountain, which is facing the ocean. So now the other side, it keeps on drying because there is this air which is descending, which also keeps on drying the land or drying the ground, because the hot air that is descending there, it is just going on to keep on descending and drying up the what? It keeps on descending and drying the what? The leeward side. That is what you need to understand. So I want you to understand and take note of this so that you would be able to relate very well. So for us to be able to understand, not to make a very long video, let us just cut it so then we can be able to now otherwise do the other part B, which is the geomorphology. Geomorphology is just going to come separate question on its own for the interest of the length of our video. Let us cut it here so that we can only be able to have climatology on its own, and then geomorphology is going to load up now. Thank you very much, and keep on coming and following. We are going to have a nice, good presentation. Thank you very much. Don't forget to like, subscribe, and also share our channel to friends and family.